Now, I will discuss the laboratory consolidation test. So, how to perform the consolidometer test using the audiometer or consolidometer. In this test, our primary object to determine the consolidation properties of a given soil sample, and this is very important parameter in geotechnical engineering. So, when a saturated mass of soil is loaded, the volume of the void decreases while the volume of the solids and pore water remain unchanged. The decrease in the voids result in escape of pore water present in them. The process is called consolidation. This test is conducted to obtain the properties of the saturated clay. The sample are loaded to a stage unit, about 90% consolidation on each of them is achieved. Now, to understand this consolidation, and you require some of the definition of application in theory of consolidation, and how you can determine the sum of the important parameter in consolidation. That parameter one is coefficient of compressibility. We will frequently use this term, coefficient of compressibility, which is designated as AB. So, this coefficient of compressibility, that is A of B, is defined as the change of void ratio per unit load increment, and both the void ratio and the applied loads are expressed on the arithmetic scale. So, this AB we can write E0 minus E, this divided by, this is sigma dash minus sigma 0 dash, where E0 is the initial void ratio, and E is void ratio for a load increment, and sigma dash is equal to load after a load increment, and sigma 0 dash is the which is called initial load. So, if you know this E0, E and sigma dash and sigma 0 dash, so you can calculate the coefficient of compressibility. So, this is one of the important parameter in coefficient of compressibility. So, you should remember this coefficient of compressibility. AB is equal to E0 minus E divided by sigma dash minus sigma 0 dash. Next, is coefficient of volume change, and that is designated as M of B, MB. So, what is MB? MB is defined as the change in volume per unit volume per unit load increment. It is also called the modulus of volume change. So, a coefficient of volume change or MB can be expressed as delta of E divided by 1 plus E of 0 into delta of sigma, where delta E is equal to change in void ratio, for a particular load increment. Okay. And delta of sigma is equal to incremental load. So, this term coefficient of volume compressibility is very important. So, that is designated as M of V, and you should know what is the M of V. For a laterally confined soil, the change of the volume is proportional to the change in the thickness. That is, let us say change of the thickness is delta H, and the initial volume is proportional to the initial thickness, that is H of 0. So, therefore, this MB can also express as delta of H divided by H of 0 into 1 divided by del of sigma dash. So, this MB also can be expressed delta H by H 0 1 by delta of sigma. So, this is the coefficient of volume compressibility. Then another term also very important, that is what we call that coefficient of consolidation. This is very important parameter, and this is designated as CV. So, this coefficient of consolidation is defined as the amount of water drained out of the void ratio of clay prismatic element in a unit time due to the consolidation. So, CV can be written as T of V into H square, this divided by T, where TB is equal to time factor. So, this time factor, let us say for 90% consolidation, this TB value will be 0.848, and this is for 90% consolidation. Okay. And H is equal to length of drainage path. Drainage is very important, and T is equal to, that is time elapsed from the start of consolidation. So, you know what is TB, time factor, H is equal to length of the drainage and T is equal to time elapsed from the start of the consolidation. This coefficient of consolidation is very important. You have to remember this equation, that Cb is equal to Tb into H square by T. Next, is compression index, and that is designated at C of C. So, this C of C is the slope of a linear portion of E log sigma dash curve, and it is a dimensionless factor. So, this Cc can be expressed as E0 minus E1, this divided by log of sigma 1 divided by sigma of 0, where E0 and the E1 are initial and final void ratio, respectively. And sigma 0 and sigma 1 are initial and final stresses respectively. So, here this compression index which is designated as Cc, and then this Cc is expressed as E0 minus Vi divided by log of base 10 sigma 1 by sigma 0. So, this compression index you can determine from the linear portion of the log E and sigma dash curve or log of P curve, from which you can determine this compression index. This is also one of the very important parameter. Then another term which you call the precompression pressure. Precompression pressure, and that is sigma 0 dash. So, it is the maximum load to which the over consolidated clay was ever subjected. It is determined by the Casagrande method of experimental empirical construction on pressure and void ratio curve plotted on the semi-log graph paper. So, from the semi-log graph paper you can determine the precompression pressure. I will show you later that how you have to determine the preconsolidation pressure, that is sigma 0 dash. So, this pre-consolidation pressure also is very important. Now, other term is the coefficient of permeability, and that is denoted by K, this coefficient of permeability. And coefficient of permeability also you can determine from the consolidation test. This is the indirect method to determine the coefficient of permeability. So, coefficient of permeability is the flow which take place through a porous media per unit area perpendicular to the flow under the unit hydraulic gradient. So, this coefficient of permeability K can be expressed as Cb into Ab into gamma W, this divided by 1 plus E of 0, where Ab is the coefficient of compressibility and Cb is the coefficient of consolidation and this is gamma W, this unit weight of water, and E0 is initial body ratio. So, from the consolidation test, if you know that coefficient of consolidation and the coefficient of compressibility gamma W and the initial body ratio, you can determine that what should be the coefficient of permeability of the soil. This is the indirect method what you can determine the coefficient of permeability. Now, we will discuss about the apparatus and the accessory required to perform the consolidation test. So, first of all that you need that how to prepare the test specimen. You need the flat glass plate, then cutting tools and the straight edge, jig for holding the consolidation ring in place while jacking out of the sample from a U tube, then water glass balance and the vernier caliper, apparatus for determining the water content. Now, how to perform the consolidation test? It is performed using an audiometer cell, and this audiometer is consist of consolidation ring, cutting ring, that is 75 millimeter internal diameter and 20 millimeter high, of stainless steel or placed brass rigid with the polished internal surface and a cutting edge. Cell body and the base, that is watertight, and consolidation ring retainer and fixed screw or nuts, leading cap and pressure pad and two porous dishes capable of withstanding the maximum vertical load applied to the soil specimen. Now, how to measure the dial gauge and the stopwatch. You use the stopwatch, take the reading, time reading, and correspondingly you measure what should be the dial gauge. For a specific time you take the dial gauge reading. Then loading frame, rigid beam supported in suitable bearing, adjustable counterbalance weight on beam, loading yoke assembly to apply vertical force to the specimen loading cap through a spherical ball on the audiometer cell, calibrated masses within accuracy of 1%. I will show you that that equipment what you can use for the to perform the consolidation test. So, here is shown that this is the consolidation, the ring, okay, and this is the porous disc, and this is the loading cap, and this is the cell body and the base. So, here is a fixing screw, here is a stopwatch, you have to take the reading of the dial gauge at a particular time, and this is basically a consolidometer equipment. Here, this is here, and then you have to apply this is a loading frame, and here load is applied, that weight, different weight you have to apply it, 1 to 4 kg per centimeter load you are applying, and at a particular time using the stopwatch you read the dial reading and continue for longer time. So, this is basically consolidometer, and then load is applied here, then you take the weight at a particular weight, you keep on take reading at a different time. So, this is some assembly for the consolidometer test. I will show you some also the line sketch here. You can see here the consolidometer. This is the soil specimen, okay, and this is porous stone at the bottom and also at the top. If the water is drained both way, then you have to place the porous stone on the top and the bottom, and then it is the metal loading pad, okay, and then you are applying the load, and this is water is outlet, and this is the consolidometer ring, okay, and this is the rubber gasket, and then load is applied here. So, it is here, you can see that how you are applying the load. So, this is the laboratory consolidation test apparatus. So, if the sample, it is a circular sample, if the sample is like this, if this is the soil, if it is the soil specimen, this is the soil specimen, and you can keep the porous stone on the top and as well as at the bottom. So, just say this is the porous stone, okay. This is porous stone, this is at the top and the bottom. Then because you are keeping the porous stone on the top and bottom, so drainage will be on the top like this, water will escape out of the from the sample, and this water escape out of the sample. So, it is a two-way drainage. Okay? This is two-way drainage. This is two-way drainage. When you apply the load, then there will be dissipation of excess pore water pressure from the sample. When you keep the porous stone at the top and the bottom, that means it is a both way drainage. And if you keep, if this is the, let us say this is the sample, okay, this is the soil sample, soil specimen, and if you can keep solid plate on the, and if you keep the bottom as a porous material. So, if this is the porous, but this is the solid and this is the sample. Okay. So, drain will be one sided, this is one way drainage. Here it is a two way drainage, here it is a one way drainage. So, drainage can be done also the one way. So, due to apply of the load, there will be dissipation of excess pore water pressure from the soil sample. So, soil sample may drain in the both way or it may be the one way. If it is a both way, you have to provide the porous stone at the top and bottom of the soil specimen, and if it is a one way, you have to keep the solid plate one side and the porous stone is the other side or vice versa. So, this way you can perform the test, and how to perform the test. So, here some procedure, the apparatus is first checked, weight and dimension of the consolidation ring is measured, the specimen is cut and trimmed before placing into the ring. I showed you what is the ring, and water content and specific gravity from the trimming is determined. So, you have to calculate what will be the water content and the specific gravity of the soil sample. Weight the specimen into the ring. The specimen is assembled into the consolidation ring. The cell is fitted in load frame and loading yoke is set up. Saturate the specimen and set the dial gauge after noting its least count, and apply the initially the sitting load, that is 10 kilonewton per meter square to the hanger. Adjust the beam to horizontal and apply load increment to the specimen. I will show you how to the load you increase in a loading table, and record the settlement reading in dial gauge at the different time interval. Plot the obtained reading. Apply next load increment after 24 hours until the 90% consolidation has reached. Then repeat the step. Remove the specimen and take the entire specimen for water content measurement. Calculate the consolidation parameter from the graph, and you calculate that what are the other parameter required for the consolidation. So, what you know that how to perform the test. I will show you next that under the how at a different interval of the time, and how you can take the reading, dial gauge reading, and different time. It is starting from, let us say, the 0, then 1 minute, 2 minutes, 3 minutes, 5 minutes, then you increase the time interval 30 minutes, 60 minutes, 1 hour, 2 hours. Like that you continue 12 hours and next day also you continue and up to 24 hours at a particular loading, then up to 24 hours. Then next again you increase the load and again you continue to take the reading at different timing. Like that you keep on increasing the load at different time up to 24 hours, and then from that reading we will calculate the different parameter, what should be the void ratio, how to calculate. So, from that table we can determine all those parameters. I will show you the next time that how we can form the table, how we can take the reading and how to calculate the other parameter, how we calculate the coefficient of consolidation and how you calculate the MV, E0, etc. Thank you.